Dear students, welcome to St. Joseph Study Center Smart Class Session, Physics Chapter 4, Electromagnetic Induction Alternating Current. In this session, we are going to learn about how to estimate the power in AC circuit, power factor, wattless current, and advantages and disadvantages of alternating current over DC current. So before estimating the power, let us recall the basic definition of power. The definition of power is the rate at which work is done or energy transferred is called as power. The formula to calculate power is what? Work done by time. SI unit watt. So same manner we can also estimate the power in a AC circuit just by knowing the rate of consumption of electrical energy. Let us see the definition. Power of a circuit is defined as the rate of consumption of electrical energy in that circuit. It can be estimated by the product of the voltage and current. So just by knowing the two parameters at particular instant, you can calculate the power by multiplying the both term. Papa நம்ம AC circuitல sinusoidal waveform பார்த்திருக்கோம். When time increases, the waveform also increases. It may increase in positive cycle or decrease in negative cycle. Yeah? So the voltage and current vary continuously with respect to time in the case of AC circuit. Let us first calculate the power at any instant and then it is averaged over a complete cycle. இந்த RMS calculation பண்ணிருப்போம் நம்ம அந்த sinusoidal waveformல ஒரு portion எடுத்து நம்ம calculate பண்ணிட்டு then we will integrate for the entire cycle. அந்த மாதிரி நம்ம இங்க என்ன பண்ணுவோம் at particular instant ஒரு particular timeல current and voltage கண்டுபிடிச்சிட்டு then we will average for a entire cycle. இதுக்கு நம்ம ரெண்டு பேசிக் ஃபார்முலா ஆல்ரெடி டெரைவ் பண்ணிருப்போம். எங்கன்னா the alternating voltage and alternating current in the series inductive RLC circuit இல்லையா அதை நம்ம calculate பண்ணிருக்கோம். voltage என்னன்னாக்கா at any instant Vm sin omega t, current ஓட value Im sin of omega t plus phi in the case of circuit is inductive. So இந்த ரெண்டு ஈக்குவேஷன் எடுத்து தான் நம்ம என்ன பண்ண போறோம் இப்ப பவர் கண்டுபிடிக்க போறோம். So we have a basic formula. பவர் என்னது product of current and voltage. இப்போ இந்த ரெண்டு ஈக்குவேஷன்ல பாத்தீங்கன்னா இந்த phi ன்றது எது இருக்குன்னா phase angle between current and voltage இல்லையா. So therefore we will calculate the pi. So when we multiply V and I, அப்ப என்ன வருது பாப்போம். Vm sin omega t multiplied by Im sin omega t plus phi இல்லையா. So we will bring out Vm Im to the front, then we have only sin omega t into sin omega t plus phi. Then the sin of omega t plus phi வந்து sin of a plus b ஃபார்முலா வச்சு எக்ஸ்பேண்ட் பண்ண போறோம். அப்ப எக்ஸ்பேண்ட் பண்ணா என்ன கிடைக்குது பாருங்க நெக்ஸ்ட் ஸ்டெப்ல Vm Im sin omega t into sin omega t cos phi plus cos omega t into sin phi. Now you take the sin omega t from outside the bracket to the inside the bracket. அப்ப என்ன வரும் பாருங்க is equal to Vm Im into sin square omega t cos phi plus sin omega t cos omega t sin phi. So பாத்தீங்கன்னா we are getting two terms. So இதுல நிறைய trigonometric term வருது. இதெல்லாம் நம்ம மினிமைஸ் பண்ண போறோம். எப்படின்னா நம்ம அந்த AC சைக்கிள்ல cos wave sin wave ரெண்டு wave மேட்ச் பண்ணும்போது நமக்கு என்ன கிடைக்கும்னா ஒரு பர்టిక్యులர் இன்ஸ்டன்ட்ல ஒரோட வேல்யூ 0வா இருக்கும், இன்னொன்னு மேக்ஸிமம் இருக்கும். அப்ப செகண்ட் ஃபேக்டர் மேக்ஸிமம் போது இன்னொரு டேர்ம் 0 ஆகும். அப்ப இந்த வேரியேஷன் இருக்கிறதால அந்த கான்செப்ட் யூஸ் பண்ணி நம்ம அந்த டேர்ம் மினிமைஸ் பண்ண போறோம். பாருங்க இப்ப ஹியர் the average of sin square omega t over a cycle is 1/2. So அந்த sin square curve வச்சு நம்ம அந்த half value கண்டுபிடிக்கணும். Then and that of sin omega t cos omega t is 0. பாத்தீங்கன்னா sin curveல பாத்தீங்கன்னா sin 0 0வா இருக்கும், பட் cos 0 19 இருக்கும். அப்ப இந்த ரெண்டு வேல்யூ நாங்க ஒண்ணுக்கு ஒன்று மாறினே இருக்கிறதால அந்த டேர்ம் நம்ம 0ன்னு எடுத்துக்கணும். அப்ப ஆட்டோமேட்டிக்கா அந்த டேர்ம் ஈஸியா ரெடியூஸ் ஆயிடுது பாருங்க. சப்ஸ்டிட்யூட்டிங் தி வேல்யூஸ் என்னது sin square omega t half சப்ஸ்டிட்யூட் பண்ண போறோம், sin omega t cos omega t 0ன்னு சப்ஸ்டிட்யூட் பண்ண போறோம் இந்த ஈக்குவேஷனை. சப்ஸ்டிட்யூட் பண்ண என்ன ஆயிடும் பாருங்க, பவர் that is average power is equal to Vm Im into sin square half ஆயிடும், sin omega t cos omega t 0 ஆயிடும். அப்ப அந்த செகண்ட் டேர்ம் பிளஸ்க்கு அப்புறம் டேர்ம் எல்லாம் 0 ஆயிடுறதால we will have only the first term. அதுக்கு sin square omega t க்கு நம்ம half substitute பண்ண போறோம். அப்ப என்ன வரும் பாருங்க Vm Im cos phi into 1/2. So இந்த 1/2 என்ன பண்ண போறோம் நம்மனா இந்த Vm க்கு Im க்கு ஷேர் பண்ண போறோம். எப்படினா 1/√2 into 1/√2 ன்னு பிரிச்சி then we are adding to the denominator of Vm Im. அப்ப என்ன பாருங்க Vm by square root 2 into Im by square root 2 into cos phi. நீங்க √2 மட்டும் ஆட்டோமேட்டிக்கா 2 கிடைச்சு denominator. So அதனால நம்ம கன்வீனியன்ட் ரீஅரேஞ்ச் பண்றோம். ஆட்டோமேட்டிக்கா என்ன பாருங்க Vm by square root is nothing but what? Vrms, that is root mean square of voltage இல்லையா. I mean Im by root is what? Irms into cos phi. So finally we are getting an average power is equal to Vrms into Irms into cos phi. So here the Vrms Irms term is called as apparent power. That cos phi is called power factor. So in this equation, we have two terms that is called as Vrms, Irms is called as apparent power, and cos phi is called as what? Power factor. So depending upon the phi value, here power will change in a circuit. So the average power of an AC circuit is also known as what? True power of the circuit. So any circuit you can estimate the power by knowing the product of VRS of IRMS and the phase angle. Next, we'll see the special cases when phi changes, how we will get the powers in a circuit. So as usual, we'll take the same base formula. Average power is equal to VRS IRMS cos phi. In that we know that VRMS IRMS refers to apparent power and cos phi refers to power factor. First, we'll take case of for a purely resistive circuit. The phase angle between the voltage and current is 0 and cos phi will be take the value of 1. முன்னாடியே பார்த்துருப்போம் நம்ம இந்த ஆர்எல்சி சர்க்கியூட்டில் இஃப் இட்ஸ் பியூர்லி ரெசிஸ்டிவ்னும் போது கரண்ட் வோல்டேஜ் இன் ஃபேஸில் இருக்கும். அப்போ இன் ஃபேஸ்னா தீட்டா வில் பி 0. அப்போ ஐ மீன் ஃபை 0 ஆட்டோமேட்டிக் கைஸ் ஃபை ஆகிடும் 1 ஆகிடும். அப்போ ஆட்டோமேட்டிக் என்ன பாருங்கள், the average power is just because of the product of VRMS IRMS. So if you take the circuit is purely resistive, phase angle 0, so cos phi will take the value of 1, we'll get only average power is equal to VRMS IRMS. See the second case. For a purely inductive or capacitive circuit, the phase angle is plus or minus pi by 2. So then automatically now cos plus or minus pi by 2 cos 90 is 0. So automatically now therefore when you substitute cos phi as 0 in this equation, the right hand side of power average power will be 0. Therefore you are getting average power always equal to 0. Third case, for a series RLC circuit, the phase angle phi is equal to tan inverse of the reactance difference, that is XL minus XC by R. இது முன்னாடி பார்த்துருப்போம் நம்ம RLC circuit. இப்போ அந்த கேஸில் என்ன ஆகுது பாருங்க, the phi is not taking the 0 or not taking the value of 1. Therefore the average power you can write VRMS into IRMS into cos phi straight away. So we can estimate the circuit for a case of RLC circuit by using this formula. That is average power is equal to VRMS IRMS into cos phi. Suppose for a case of series RLC circuit is at resonance, the phase angle is 0. Now we will take the resultant which is in phase with the voltage. Automatically the cos value is again going to 1. Therefore the average power is equal to VRS into IRMS. So here you can see the four cases that depending upon the angle of phi. So just because of the angles of phi, we will get a different powers in a circuit. The next topic is wattless current. By making use of the idea of power in a circuit, we also find the type of current flowing in it. There are two ways you can, namely wattful current and wattless current. We'll see how to name it. In order to find the current whether wattless or wattful, we consider a circuit in which there is a phase angle of phi between Vrms and IRMS, and voltage is assumed to be leading the current by phi as shown in the phase diagram. Let us take a phase diagram in which you can see that the IRM is parallel to x-axis and the Vrms is leading the current by an angle of phi. So this is a case we are taking. From this phase diagram, we are going to estimate or we are going to find whether the current is wattful or wattless. So in order to find that, we are going to resolve the IRMS into two components, namely horizontal component and vertical component. So when we resolve IRMS, we will get two components, namely this IRMS cos phi is along the direction of Vrms, and the other component IRMS sin phi is perpendicular to the Vrms. So now we split into two components. So in that you can see that this IRMS cos phi and Vrms are in phase with each other. The component of current IRMS cos phi which is in phase with the voltage Vrms is active component. The power consumed by this current is a product of Vrms IRMS cos phi, so that it is known as wattful current. Now come to second case of the other component IRMS sin phi which has a phase angle of pi by 2 with the voltage. See the diagram, this IRMS sin phi is how much degree inclined with the Vrms? 90 degrees mentioned in the green color. So 90 degrees, 5 by 2. So once it is 5 by 2 with the voltage, this component is called as reactive component. The power consumed is 0 because if you put 90 degrees in cos phi term, it will become 0. The entire right hand side term becomes 0. That is power will be 0. Hence it is also known as wattless current. So here also this 5 only deciding the current, whether it is wattless or wattful. So if the 5 value is 0, that is, if the active current is parallel to VRMS, then we will easily estimate the power which never be 0, which is known as wattful current. If the 5 value is 90 degrees with the voltage, that is the phase angle of 90 degrees with the voltage and current, then it's going to be reactive component and no power is consumed. So the power consumed is 0, hence it is known as wattless current. So this way you can identify whether the current is wattful or wattless. Therefore the current in AC circuit is said to be wattless current if the power consumed by it is 0. The current is said to be wattful if the power is consumed. So this wattless current occurs in a purely inductive or capacitive circuit. Now we will see the special case of power factor. So we know already that the average power over a cycle is given by product of the two terms, namely apparent power and power factor. So the product of VRMS, IRMS is called as what? Apparent power, and the cos phi is called as what? Power factor. So in this term, we will see the specialty of power factor now in detail. So the power factor of a circuit is defined in one of the following ways. So we can define in three ways. We will see the first way. Power factor is equal to cos phi is equal to cosine of the angle of lead or lag. So once you know the angle between the current and voltage, so you can call the name as a lead angle or a lag angle. So if you take the cosine of that angle, that is called as what? Power factor. The second definition of power factor is R by Z, that is the ratio between the resistance and impedance is called as what? Power factor. The other way you can define is the ratio between the average power divided by apparent power, that is PAV divided by VRMS and IRMS. These are the three ways you can define the power factor in a circuit. See some examples of power factors in a circuit. In the first case, the power factor is equal to cos 0 is equal to 1, because if you take the current and voltage are in phase with each other, so phi will take the value of 0. So when you put 0 in that formula, the power factor will take the value of 1, because the phase angle phi between the voltage and current is 0 in a case of purely resistive circuit. So in a case of purely resistive circuit, the power factor will take the value of 1. The power factor will take the value of 0 when the phase angle between current and voltage is for 90 degrees. That is given here. Power factor is equal to cos of plus or minus pi by 2 will take the value of 0 for a purely inductive or capacitive circuit, because the phase angle of phi between voltage and current is plus or minus pi by 2 in a case of purely inductive or capacitive circuit. The third case, power factor lies between 0 and 1 for a circuit having R, L and C in varying proportions. So we can estimate the power factor just by measuring the phase angle in a circuit. If the phase angle is 0, the circuit is purely resistive. In that case, power factor take the value of 1. So in a case of circuit is inductive or capacitive, then the phase angle will be never be 0. It will take the value of 90 degrees. In that case, the power factor will take the 0. So the power factor can take values between 0 and 1 in a case of circuit having varying proportions of R, L and C value. Is it? Now we'll see the advantages and disadvantages of alternating current over DC current. We'll see now first advantages. The first advantage is the generation of AC is cheaper than that of DC current. Next, when AC is supplied at higher voltage, the transmission losses are small compared to DC transmission. We already studied transformer. In that, we transmit the current to very long distance by raising its potential difference. So this way you can transmit without much loss. Next, the AC can easily be converted into DC with the help of rectifiers. So conversion of AC to DC is very simple with the help of rectifiers. We'll see now disadvantages. Alternating voltages cannot be used for certain applications such as charging of batteries, electroplating and electric tractions, etc. Certain instruments use a small amount of battery which need to be work on a DC current only. So in that case, we have to convert AC to DC. We cannot use directly AC alternating current. Second case, at high voltages, it is more dangerous to work with the AC than DC, because when you have a high potential difference, huge current will flow that may damage or hurt the persons working with it. So it is dangerous to work with the high voltages. So these are the advantages and disadvantages of AC over DC current. Thank you, students.